Okay, the tricks today, this is also like a pre-exam little session that we're going to have today. So what we're going to do is we're going to go through November 2018. And we're going to go through question, well, it's paper 1, of course. Sorry, paper 2, not paper 1. That would have been awkward. And we're going to aim to do question 4, 5, 6, and 7 of this paper. Okay, which seems to have, this is upon request, of course, and some from last week and one also from this week, added in question 6. So we're going to start with question 4 first. Okay, question 4 is a organic chemistry question. It's the last organic chemistry question, or should be the last question, depending on the structure of the question paper. So I'm just going to pull up the question. So this one is question 4, and of the November 2018, as it says over there, so I'm not lying. It says that 3 reactions of organic compounds from the same homologous series are shown below. So they all belong to the same homologous series. Can anyone tell me which homologous series all 3 of these reactions belong to, or organic compounds belong to?
Is it alkane?
Alkane is correct. The reason why we know that is we have butane, we have pentane, and hexane. They all end in the suffix ane, which is from alkanes, and that's the homologous series that they belong to. That's how you recognize the homologous series. Great. So we're already one step closer. The first question in 4.1.1 is to define a homologous series. Okay, now this is just a definition, so I'll just show you the definition because you actually have to learn it. Homologous series is a series of organic compounds that can be described by the same general formula or by the same functional group. Okay, so the important part here in this definition is it's a series of organic compounds, so this bracket part is important, as well as the underlined section here of this definition. So what you need to mention, it's a series of organic compound, and that it can be described by either the same general formula or the same functional group. Either one is up to you. Another definition that you could also just define it as is taking a series of organic compounds in which one member differs from the next by a CH2 group. That one's a little bit more trickier to remember. I prefer the first one because the first one is more textbook. It's more textbook related, of course. It's plucked exactly almost from a textbook, saying that it's described by the same formula or same functional group. That was 4.1.1. Great. Alright, 4.1.2. Name the type of reaction that is represented by number 1. Now the first one, we have butane plus bromine, Br2, which gives us 2-bromobutane plus P. Okay, quite a unique reaction happening here. We just want to know the type of reaction that's represented by the first one. So maybe I'll write that down for 4.1.2. So for 4.1.2, just make this slightly smaller. We have butane. Okay, and we add in bromine, Br2, and we get 2-bromobutane. Alright, and we have a unidentified compound that also forms as a byproduct. And we want to know the type of reaction. So what is the type of reaction that takes place here? Can anybody tell me? For the people that are watching this video, the answer that was given to us in the interim was the answer substitution by a human being that we shall not identify for the purposes of integrity and identity theft. Substitution was the answer that was given. So let's go have a look and check. Oop, computer's going crazy. The answer is correct indeed. Substitution is the correct answer for this type of reaction. Okay, well done. Thank you very much. The type of reaction, it is substitution, which makes perfect sense. Okay, because all we did, we have clearly substituted bromine in because we have 2-bromobutane. If we must draw the structural formula of butane, we'll see that on the second carbon will be the presence of 1 bromine atom. Okay, so that was for 4.1.2. 4.1.3 says write down the formula of the inorganic compound P. So they telling us that compound P that forms is actually not an organic compound, but it's a byproduct that forms. Okay, now when you're doing this question, it is essential that if you cannot see what's going on here in this format, to draw structural formula. I'm a visual thinker, so what I would do when I was writing my exams, I always made sure, well, besides the fact that I knew my organic chemistry very well, like I walked away with 85% with an organic chemistry paper that was just organic chemistry. I walked away with 85% for it. So I learned it extremely well. So much that when it came to this stuff, I never ever forgot how I got to the level that I was at with my organic chemistry. The reason why I got good at organic chemistry is because I learned structural formula very well. So where I'm able to look at a name, an IUPAC name, which is like butane, and able to draw it structurally. So I see I've got 2-bromobutane as my byproduct. Okay, so if I have 2-bromobutane and I know that was a substitution, then I know that bromobutane is going to look 2-bromobutane is going to look like this. There's going to be my bromine. Okay, now all the other these little blank spaces here, obviously are places for your hydrogens. Okay, remember, you're not drawing it for marks now, you're drawing it to help you figure out what is P. So I had butane plus Br2. Remember, bromine is a halogen, it cannot exist on its own. It has to bond with another one of its own kind. That's just the law of physics, chemistry rather. So, if that's the case, that means I substituted bromine in for a hydrogen, which means I have a hydrogen hanging that can bond to another bromine, because I had 2 bromines here. Only one went in here, so this means I still have another one. It doesn't magically vanish. So therefore, compound P must be whatever was remaining. HBr. Hence, the inorganic compound is HBr, or if you wrote it as HBr. I think the first one is the correct way, so I'm going to take the second one away. HBr. Okay, hydrogen bromide. 4.1.4 says, give the structural formula of a positional isomer of 2-bromobutane. Okay, so positional isomer means to change the position. Correct? I mean, it tells us that. A functional isomer, which means we would change the functional group almost, or change also the homologous series. If it was a functional isomer, but we just want a positional isomer. Okay, just change the position. So if I want to change the position of 2-bromobutane, well, okay, 2-bromobutane means it was on the second one. Okay, so obviously I have to draw in my hydrogens now because this is for marks. I can't not draw it in there. Okay. Okay, and maybe I want to put it, okay, let me put that hydrogen there, but maybe I want to put the bromine here. There we go. I changed the position. Alright, remember? I'm going to count this one, I'm going to count my first one, so now I just have bromobutane. This would just be bromobutane now, because it's on the first one, because remember you want to count from where, to make the molecule, or the chain look smaller, so you're going to count from this side, and not for bromobutane, but rather from right to left, so it's just going to be bromobutane. and you've just changed the structural formula. Or the position, sorry, rather not the structural formula. That still stays the same, but you've changed the position of the bromine, so it's no longer 2-bromobutane, but just bromobutane now. 4.1.5, using molecular formulae, write down the balanced equation for reaction number 2. Okay, now reaction 2 is pentane. Okay, so let's go ahead and let's just do that. Let me just change layers quickly so I can fit this in. This is 4.1.5. Okay, 4.1.5. This one is, so we got pentane, so it should be C5H2 plus H12. That should be that. And we have plus oxygen, so plus O2. That should give us carbon dioxide plus water. Okay, and now we got to balance out this equation. So just check. Yes, that's it. So pentane, pentagon 5 plus excess oxygen. Obviously heat is given off because it's combustion, and we get a certain product and blah blah blah. So we've just got to obviously balance the equation for this one. So let's have a look here. I got 5 carbons here. I've got 1. So if I put 5 there, 5 carbons. And now I've got 10 and 11 oxygens. So let's balance my hydrogens now. 6 times 2 is 12. Okay, I've balanced that. Now I've got 5 times 2 is 10, plus 6 times 1 is 6, so it's 10, that's 16. And an 8 goes in front there, that's 16 oxygens. The question is probably like, how would I have known that pentane looked like this? Remember, there's a general formula for alkane, and that is it's CnH2n plus 2. Okay, that's the general formula. So all I did is I knew that the pentane was 5, so that's 5 carbons. Alright, and then 5 times 2, obviously 10 plus 2 is 12, and that's how I figured it out. Okay, so learn your general formula as well, guys. It will definitely come in handy. Then for 4.1.6, they first tell us that reaction 3 is an example of cracking. Okay, define cracking reaction. Okay, basically cracking in a nutshell, before I show you the formal definition for it, cracking is basically breaking up long carbon chains into smaller chains, which can be of more use. Okay, that's paraphrased, but the formal definition for cracking is that it's the chemical process in which longer chain hydrocarbons or longer chain alkanes, okay, are broken down into shorter or more useful hydrocarbons, such as alkanes and alkenes, put together. So having a look at reaction 3, we have hexane, which is 6 hydrocarbons, and breaking that down, of course, into smaller bits. So it is a chemical process by which you take longer chain alkanes and you make them into shorter, more useful hydrocarbons or more useful alkanes and alkenes. Hope everybody has caught that for 4.1.6. 4.1.7, it says give the structural formula of the organic compound Q. So once again, structural formula can help us out here. So we have, although I'll teach you a trick to obviously not write out structural formula. So you see we have hexane here. So hexane is, again, the alkene general formula. So we want hexane, so that's C6. 6 times 2 is 12. That should be H14. Okay, that gives us C2H4. Now that definitely looks like an alkene. That definitely looks like an alkene formula. So if I have 6, I had 6 to begin with, and I'm cracking it and I'm making it shorter, I can clearly see that I only have 2. So I just want to check what they want us to write the structural formula of compound Q. Remember, so this is not our answer, this is just us helping us with the answer. So clearly, if I only have 2 in this one, then the other molecule, compound Q, must contain some C4, which is ironic because C4 explodes. But anyway, C4. And I only had 4 hydrogens there, so my remainder must obviously be 10. That way, if I add these two together, I should get boom bada ba, hexane. So C4H10. Now that I've figured out what organic compound Q should look like in terms of carbons and hydrogens, I can go draw it. So C4. Alright, so 1, 2, 3. So now you actually have to draw in your hydrogens here. That's 3. That's 3. That's 3. That's 3. And there we go, H10. Now what does that look like to you? Anybody? Butane is what it was. Fantastic. That's compound Q. Almost done with this question. We have 4.2. 4.2 says study the flow diagram below, which we have 2-bromobutane, which undergoes a hydrolysis. We get compound R, and then we also have an alkene that is formed. They want us to write down the IUPAC name of compound R. Now, when you undergo hydrolysis, you're basically adding the OH molecule to your alkane or to your organic compound when you undergo hydrolysis. That is a type of obviously reaction that does take place. Okay, and if you need to look in your textbook again and revise the types of reactions that take place, please do so before this week's paper. So we want to find the name of compound R. So if I'm adding OH, I know, according to knowledge of organic chemistry, that any organic compound that contains OH, okay, must give me an alcohol. Okay, this is the functional group of an alcohol, of course. Okay, if I have C, okay, that's bonded there, but if I have an OH present there, I know that this part here is the functional group of an alcohol. So if I'm undergoing hydrolysis, okay, the bromine in 2-bromobutane is going to come out, and the OH is definitely going to replace it. Okay, so if I do that, then that's going to give me, or it should give me, if that replaces the bromine, it should give me for 4.2.1 the compound R. The name for compound R should be butane 2O. Butane 2O, alright, or 2-butanol, but butane 2O sounds more like it's correct. Sounds like a better name or better way to write it. So definitely butane 2O would be the correct name for that compound R. 4.2.2 says compound R reacts in the presence of concentrated phosphoric acid to form an alkene. Write down the structural formula of the major product in this reaction. Okay, so as mentioned already for 4.2.2, is that when we react anything with an acid, we usually get a salt plus water. So if we had butane 2O over here, I'm just going to omit the hydrogens just for now, and we had the OH group over here, then what would happen is that if we reacted anything plus an acid, we usually get not an equal sign, sorry, we get a salt, okay, plus water. Okay, and obviously water we know is going to be H2O. So the salt over here in this part here would be our alkene that forms. Okay, and all they want us to do is just draw the structural formula. Well, water, I know that there's going to be the presence of that OH is going to leave, and one hydrogen is going to leave pretty close to that. That's going to make up, of course, the H2O part here. So if those two disappear, there's nothing on this arm and there's nothing on that arm. So obviously they can combine over here and here to obviously form another arm present here. So we'll still have 4 carbons, except that there'll be a double bond over here. So let's draw in our hydrogens quickly. So we'll have a hydrogen there, have a hydrogen there, or we could have swapped it out actually. Let me just swap it out. Sorry guys. Okay, so that hydrogen stayed, that one went, and that one went, so that one will obviously stay. And we get hydrogen, hydrogen, and hydrogen. So this part here, of course, was the answer that we were looking for to actually draw the alkene that was formed, which you can see would be, if we had to write down the name, it would be but2-ene, showing you that the double bond is obviously on the second carbon, but2-ene. From both sides, if you want to count from left to right or from right to left. And that was question 4.2.2. And we can see that that was for 17 marks, this question. It's quite a big, lengthy question, and all the organic chemistry questions are, in fact, but this is question 4.2 and wraps up question 4 of the November 2018 paper.